Okay, anyways, my name is Maureen Szymanski, and I work at the Air Force Research Labs. I'll give you like a quick life story, I guess, as quickly as possible, because really I'd rather, take questions. What do you guys want to hear about? So, I grew up in Cleveland, Ohio, so I've been a Browns fan forever. It's only recently been a good thing, but then when I graduated high school, I knew I was good at math, but I didn't really like it. So I didn't know what I was going to do with it. I got to Denison University is where I did my undergraduate studies. And during like the original orientation or whatever, my counselor suggested that I take a physics class, and it was called Quarks to Cosmos. So it covered, everything from the smallest particles to galaxies. And that was it. I was hooked. It was incredible. There's something about applied math to something real and physical that I could, see the results, that the math predicted reality. Just really captured my attention. So I got my bachelor's degree in physics. And, the good news about physics is you can use it to do anything that you want. I learned how to problem solve and computer programming and things like that. I could have applied that to any job I wanted. So, what I did to decide was internships and summer research. So I firmly believe that internships are the only way for you to figure out what you really want to do, is to try it. And so that's what I did. My first summer, I did astrophysics research and hated it. So that was not for me, which is just as important to figure out. So then the next summer, I applied to do an internship at NASA Glenn's Research Center, which is in Cleveland, Ohio. And I did optical research while I was there, and I loved it. So that was the first time that I found myself, looking up research papers and reading articles without it being a homework assignment. And so that's when I decided that optics was where I wanted to go. Through some connections with my professors, actually, is how I ended up at UD. My professor's wife's PhD advisor started a program, and I got my master's degree in optical engineering. And while I was working on that, I actually did my thesis research on base in the building that I currently work in, with the people I currently work with. So that's how I got my foot in the door on base. I've been an optical engineer there for almost 8 years. And a few years ago, I decided to go back, and I've been working on my PhD. So hopefully I'll have that done, in the next year, which I've been saying for 3 years. So it'll get done. But anyways, so I work as an optical engineer now, for the Air Force Research Labs. I do laser radar research, which is a lot like regular radar. So, if you guys have more questions about that, we can talk about it. And I love it. Part of the reason I decided to go back and get my PhD is because I'd like to stay technical. So I'm actually going to get a PhD and not teach, which is, I think there's a perception that PhDs mean you have to be a professor. But in my case, it means that I get to progress in my technical career path instead of becoming a supervisor. So that's pretty much it. And now I want to, oh, sorry about that. Hopefully you guys didn't hear my calendar just blink, but so what interests you guys? What do you want to talk about in terms of career development or questions you have in terms of picking a path and things like that?
That's a good question. So like I said, this is my introduction to biotechnology class. And so we've got Kayla and Sarah on here right now. We have one more student in this class, and hopefully she'll join us at some point. But really, my goal with this is just to kind of share what you do. And Kayla and Sarah, if you have any questions, so Maureen is here and she's talking about her background. And do you ladies have any questions about career paths in science, and kind of anything jump out at you? Okay. So I can sympathize with being a Browns fan.
I just love them. Thank God they're good.
That's what my husband is one, and so I think I sympathize by proxy. So what were you gonna say? I didn't mean to cut you off.
What's biotechnology? What do you learn in your biotechnology course? What does that cover?
So the biggest thing is kind of the definition we go with is that biotechnology is using living things or parts of living things for some kind of beneficial outcome to humans. So we talk about genetic modification, genetic engineering. My students learn about, we kind of started the year with microbiology. Excuse me for a minute, my own kids are wrestling right now. The joys of having your own children at school with you.
Mm-hmm.
Apologies.
Okay.
So we kind of start off the year, and my intro class is a little bit different. It's geared towards freshmen and sophomore students. And then I also teach the career tech program, which is juniors and seniors. But overall, we learn about what is biotech, lab safety. We get into microbiology, just like the basics of microbiology, how to make agar plates and grow bacteria and stain things so we can look under the microscopes. And then we talk about DNA, how to isolate it, how to analyze it. Then we get into kind of combining the two. So we talk about taking DNA and transforming it into bacterial cells to produce a product, a protein. And we, that's kind of the main thing that's going to happen in the intro to biotech class. After that, if they decide to come into the career tech program or with my juniors and seniors, we talk about proteins, we talk about how to isolate and analyze those. But again, the whole goal is to develop products. And so I kind of show them the techniques so that they can then utilize those techniques as seniors to do senior research projects. At least that's the goal.
That's awesome.
Yeah, it's fun. I feel like I'm always trying to change things up because I'm like, oh, we could try this. We could try this. CRISPR is the hot, topic right now. And so there are some labs out there where we can utilize CRISPR and things like that. So just to give them a little bit of science that's fun and make us become creative problem solvers.
Yeah, that's incredible. I feel like we didn't have any classes that were that unique when I was in high school. There were, well, I took a physics class, we had biology and chemistry, but nothing as applicable, I think, to the real world as what's really is going on. So that is really incredible. And I mean, those skills are transferable to anything, which is what's so great about courses like that. So Sarah, your light system is pretty incredible.
Thank you. They're like actually Christmas lights, so they're supposed to be, or at least those ones. They're supposed to be outside, but they aren't. So
love it. Yeah, I don't know too much about biology. Although the conferences that I go to for our research, the optical engineering research, I do laser radar research for the Air Force. So, our whole thing is about longer ranges and how far can we see with high resolution and things like that. But a lot of the conferences are split. The new thing with it's the same concepts that we use to get high resolution. They're using in microscopy. Did I say that right? Yes. And so they use what's called digital holography. So you can measure actually the full field, the amplitude and phase, and use that to get higher resolution so you can see smaller and smaller objects for things like microbiology. So it's really interesting. It's just I don't use it at work. I can't apply that to the Air Force. So.
That's pretty cool. I would love, I'm in a high school science room to do this. And so we don't have, I eventually would like to get fun equipment or try to work with people that do, but like confocal microscopy where they're using fluorescent molecules that's kind of cool stuff.
Mm-hmm.
So
that sounds amazing. I think biofluorescence is one of the coolest things.
Yeah,
I don't understand it, but I think it's one of the coolest.
I don't think I understand all of it either, but it's a pretty cool tool. So do you ladies have any questions? Why don't you tell her like what you're kind of interested in terms of science or career fields or things like that?
I mean, I'm definitely interested in becoming a forensic toxicologist. I always thought that was That and a forensic psychologist. I always thought those two were very interesting, at least to me.
That's really cool. Have you looked, are there any places you can do internships and something like that in the Dayton Kettering area, I guess?
Yeah, I mean, I'm only 14, so there's not really
So,
many options, or at least as of right now, but that's something I have to look into.
well, people love high school volunteers. So if it's close to home and you can handle not getting paid, a lot of places will take extra help if you can find it. So, be proactive. And if someplace sounds cool, give them a call and try it out. So maybe they'll make you wait
Yeah,
until you're
totally.
16.
So,
Hmm?
and, yeah, I mean, probably because I like just turned 14, so I mean, I have a little bit of time to kind of figure it out,
You have
but
plenty of time. Don't feel rushed. I was just thinking if it was something you liked. Oh, my internet's unstable, so hopefully I don't cut out.
I was really interested in like microbiology and I liked cell culture. I thought that was really fun when we, did the agar plates, things like that. I'd like to work with that kind of field.
Cool. That's really interesting. About the other Kayla.
I've thought about like doing like being a blood splatter analyst in forensics and everything. I thought that'd be really cool. It's just interesting.
Well, absolutely. I mean, you guys have some cool stuff. When I was your age, I was like, I guess I'll work as a cashier at Giant Eagle for a little while. But oh, you guys don't have Giant Eagle, like Kroger, I guess. No, that's awesome. And like I said, my only recommendation would be try and get as many, real life internships or hands-on experience, anything you could do to like try it out and see, whether you like it day to day and things like that. So, but all those jobs are super interesting. So
Yeah, and that's part of the career tech program at Fairmont, or any career tech program, is like juniors and seniors can go out and work.
That's
Most of the
awesome.
time it's seniors, they can go work in a lab, or they can go, anywhere that will take students. They can go work with them and stuff like that. So I try to give them some applied science they can use, and then hopefully we can try to connect them. But
They do have, it's not as common, of course, but there are biology labs on base at Wright Pat. They're almost all exclusively in the 711th Human Performance Wing is what they call it. So basically the point of the research is to, figure out how best to use our people, I guess. So the work I've done with them is looking at, how the airmen can interact with technology, but then they also have, that's where the School of Medicine is in the Human Performance Wing. And so they do all kinds of biology and microscience work. So actually toxicology is probably in there too. So, if that was something you guys are interested in, I'm sure there's internships through Wright Scholars and the Air Force
yeah,
Research
I was
Labs
actually
there.
talking with UES
I'm sure there's
about
internships elsewhere.
some of their stuff. So I don't know if you guys work, UES is like, that's the contractor at the base. So I've been kind of talking with them about trying to find some spots for students and things like that. I have a question for
That's
you.
Cool.
So when you were going through and kind of like going through your school and stuff like that and trying to figure out what it is you wanted to do, what, like, I guess when you were in high school and you said you were like, I'm good at math, but I don't really like it. But like, what are some of the skills that you feel like that we could practice in high school to help us kind of hone in on our science or hone in on trying to figure out a career, things like that?
Absolutely. I think that understanding math as a language, I think, is huge. I didn't learn that until much later, but understanding how to do, basic math and being able to apply it to, all kinds of problems. And then that was a big one for me. Especially for you guys now, the world has changed since I was in high school, but anything you can do to understand computers, even basic computer programming, you'll use it for your models for microbiology and toxicology and blood splatter. I can't imagine the simulations they have for that. So it's not just learning, multiple languages or anything like that. Once you understand how to program, that's a skill that you can transfer to any other language, and it helps you learn how to model and how to use the computers as a tool to answer the questions that you have about the real world. So that was one that I wish I'd done more of when I was younger instead of learning it on the job. And then honestly, I think the greatest skill that I got through high school and college was just learning how to problem solve and ask questions and make sure that, you know, when you're given a piece of information, whether it's, you know, homework problem or, you know, some kind of assignment, really drilling down and asking, do I really understand this? So being able to ask those questions and make sure that, you know, you're not just learning something for a test, but that you could actually like explain it back or teach it to somebody else. Being able to internalize what you're learning along the way is a skill that how to study, I guess, is a skill that I don't think a lot of people develop until much later. So, you know, those are the things that I would work on, I guess, as early as possible.
Thanks. That's helpful. I had to move to my back closet. It was getting a little noisy out there. Do you feel like if you physics, what else would you have gone for?
If I didn't do physics,
Mm-hmm.
I actually, well, let's see. Before I started my master's, I was really into medical imaging, but that was later. When I started, actually, I studied film for a couple of years. I did a minor in cinema. One of the things I was really interested in was not being on camera or anything like that, but I always thought the special effects were cool, the physical effects, you know, how they did like the miniatures and the stunts where they're pulling people through walls and things like that. So I actually, that was my first plan when I was studying physics, was I was going to do physics and cinema because I love movies. And I was hoping to turn that into a career doing stunt, I don't know, design, I guess, and engineering. So that was something I looked into. I am really glad that I did physics first because it gave me a really broad understanding of the world that I could build on later, you know, as a good foundation. But there are other engineering programs that in hindsight, I think would have been really cool. And it's a different perspective, I think, on the world, on how to apply what you know and what we've already learned to design, you know, something new, design the future. So that's something I wish I'd explored a little bit more when I was a senior or junior in high school. But like I said, at the time, I had no idea what I wanted to do. So that's how I ended up kind of where I'm at. But I'm glad I found optics. That's my thing. So, and I really like it in terms of imaging and how to, you know, image small things that are far away, or you know, what else can we learn from, you know, light? It's got all kinds of properties that I just need to be able to decode. And I think that's really cool.
You mentioned too that you do the laser radar research, and you said something that's different than regular radar. So what are the differences there?
Yeah, the main difference is just the wavelength of the light or the color of the light. So in laser radar, we use optical wavelengths. So that means they're short enough that they're like the ones we can see, colors we can see, or maybe a little bit longer than that. So infrared. And what that does is it gives you much higher resolution that you can measure. However, it also interacts with the atmosphere differently than radar works. So the way that both systems work, what radar means is it's ranging and detection. Okay, so basically we know the speed of light. That's a constant. We've measured it. We know it. It's a known thing. So if I time how long it takes my pulse to get from me to the target and back, I can back out the distance that it traveled. So with laser radar, what happens, I need something to point at. Okay, because my wavelength is so much smaller, I can get higher resolution. So I could actually measure the range to like multiple parts of this cup and get a 3D point cloud or a 3D image. So they've used that for all kinds of really cool work. Some of my favorite stuff is they've published, they're doing archaeological research in South America where they're looking under canopies, you know, so it's a lot of these places in the jungle where you can't get to, you know, the expedition to walk and search, and under the trees, you're never going to be able to see what's there. But using laser radar, you can take multiple ranges to the top of the canopy, you know, lower in the trees, and then see if you can get hits off the ground. And then using computer programming, you can process that data and remove the canopy and see like what was underneath. And they've actually found all kinds of ruins of ancient civilizations that, we never would have been able to find before, with a man on the ground, boots on the ground, searching through the jungle. So they're also using it. One of the newest applied things for laser radar is for autonomous vehicles. So they're trying to figure out if they can use it to make cars drive themselves. Honestly, I think radar is super useful for that too. So, but laser radar gives you that increased resolution. The problem is that you can't, because of the wavelengths, they're absorbed by water. So rain is a problem for us, and so are clouds. So trying to figure out, how to compensate for atmosphere and things like that is a huge effort in terms of research for laser radar. So those are the differences.
That's cool. That would be fun to be able to use that with cars, but yeah, you'd have to live somewhere where it's not wet.
Yeah, and I mean, being able to, I guess you could see the rain, but it shortens the range. So, you could see a car in front of you, but not one this far in front of you. So it changes how useful it really is.
Yeah. Okay. What does your typical day look like? I mean, right now it's weird. So
right now
let's
is
just
weird.
not go with what it would be, not what it would be like right now, but what would it look like normally?
Yeah. It's actually doubly weird right now because I'm working on my PhD research, and that is my job. I was able to get external funding to do my dissertation work as part of my job. So right now is a little strange because I'm on a team of one, which is not the real world. Group projects are how things go. But typically, there is a lot of emailing that happens. One of the things working for the government, we work with a lot of contractors. So there is some like program management where, we have funding and we don't have the resources to do all the research ourselves. So we contract it out and we hire people that are professionals. So part of my day is meetings with, other scientists at other companies to see how they're doing. They're making new detectors or designing new lasers or, things like that. So that is part of it. Pre-pandemic, I actually did a lot of travel for that. Which is good and bad. It depends on if you like to travel. I love to travel, so it wasn't a problem. I got to see some really cool places. I've done conferences in Hawaii and France and all over the United States. And you do meetings with the contractors, or you see their labs and see kind of what they're doing. And then the rest of my day would be, usually it's split. I go back and forth. We do a lot of simulations, modeling and simulations, in order to do our design, because engineering is all about, taking the things we know about the world, the known, things I can't change, how the world works, and designing a solution to a problem to help humanity. So we always do that in models first, computer simulations, because it's cheaper and it's easier to figure out, what will work and what won't without building something 100 times and having it fail, like Edison did with his light bulbs. He could design a light bulb a lot faster if he had a computer to try all those different methods out. But anyway, so that's the first step, is to, build your model and simulation. So a lot of days I'm doing that. And then once you get something in your model that you, think is going to work, the next step is to try it in the real world. So we have labs on base where we test all that stuff out. When I'm done with my PhD, what my life will look like is I'll have a team under me who will do most of probably the lab work. I'm hoping I can stay in the lab sometimes, but we'll work together to get all of those things done, because that's a lot of work, the simulating and the, lab testing to prove out your concepts. So, and then what usually happens is we don't produce the laser radars for the Air Force. That's not our job. So we would contract that out again. So we'd work with other companies to build it to scale so that, you could transition it so that the warfighter can actually use the systems. So that's what my day is. It's a lot of some meetings, a lot of computer simulations, and then the lab. Hopefully that's where you want to get, is back in the lab. And then data processing is back on the computer again. So
yeah. So do you have, like, in your labs, because I'm more familiar with like a biology lab because I worked in biomedical research. So in your labs, you just have like different equipment, different wires, different like materials that you can kind of just put together as you need to?
Yeah, the standard optics lab, it all starts with special tables. We have these very fancy tables. Once you've been in one optics lab, you've seen them all. They all look very similar. They all have these same tables. And what's cool about that, so the top is It's just like a grid of screw holes so that you can attach things to the table. But what's neat about them is they usually float. My internet catch up. Hang on a second. Okay. So usually the tables float because our systems are so sensitive to vibration that you want to isolate them. So all the tables float, which is kind of interesting when you're trying to like align things. And then we have drawers and drawers of, lens holders and posts to hold things up and things like that. And then we do a lot of work with optical fibers to help get light from one place to the other. So, you'd set up a laser and then you'd have an optical fiber that would take it to your free space system, which would be a lot of lenses, collimators. We use some like LCD screens to do light modulation and things like that. And so then you'd have free space lasers, and so you got to have mirrors and all kinds of stuff bouncing everywhere until you finally get to, in our case, you bounce it off a target, and then it has to come back through some more optics, focus it like my glasses do onto my camera detector or the eyes of my system. So that's typically what our places look like. So, they look a little bit different depending on what you're doing. If you're doing laser research, it's tables and tables of lasers and chillers and things like that. The detector fabrication labs are something I'm kind of just learning about now because they use a lot of the same concepts they use to make like computer chips. And so those labs are really cool with vacuum chambers and deposition systems and things like that. But that's kind of a new thing for me. I never really understood that until recently. So my labs don't look like that. Let's see what else. But yeah, that's pretty typical, is those floating tables, and then you add your system on top of it. Actually, in a lot of the European labs, they have vertical ones because the lasers don't know which way they're pointing. So they'd actually be like standing up, and you would attach your mirrors and things this way, and the beams would bounce. So it's a little less eye safe.
Do they,
if you're
like,
careful,
how do
I
they
guess.
float? Are they like on wires and they float? Is that how they're floating? Or are they like?
No, they're on
something pulls them
hydraulic
up?
legs. Okay. Yeah, the legs are
fun.
air pressured. So every time you
Okay.
lean on your table, it like hisses as it levels itself out. So when I worked at
it's like a
NASA,
bus.
actually, yeah, it's like a bus. The lady I worked with at NASA was doing optical tweezer research, and she had this huge 4 tables, they were all together, systems set up. And in order to get to anything, she actually had to walk on her tables to like align it all up. So it was just like hissing and she like walked on her floating tables. But yeah, no, that's a typical optics lab, or floating tables.
Okay.
And
that
lots
sounds
of
fun.
lenses and mirrors and lasers. So.
Yeah.
All
right.
Yeah, and then mostly for us, for lab safety, the biggest risk is eye safety. So
yeah,
that's what usually we have to wear goggles, and it's just being cognizant of where your beam is and how it's reflecting. So
yeah,
but we don't usually have too many like chemical safety or anything like that.
Yeah, that's our fun lab. We have lots of chemicals and biohazard. That's always a good one. Although in a high
we
school
do
lab,
not hopefully you don't have any biohazards.
Yeah, and we treat it like biohazard, but everything we use is pretty safe unless we accidentally culture something, when we're just swabbing the environment. We just don't open those plates and we leave them shut. I don't know.
You're gonna find.
Yeah, who knows? Yeah, we look at it and then I like look things up and I'm like, well, that's an orange colony, so let's see what that might be. And then I'm like, let's not study that. That's more for college. We use safe stuff. Like we use E. coli, but it's called K12 E. coli. So they mutated it so it's safe for K12. Let's see.
Wow.
Kayla, and Sarah, do you have any questions that have popped in your head? They weren't expecting a guest speaker today, in fairness for them. The way I had this set up, you were going to talk with my seniors. But I was like, surprise, the schedule changed. Totally fine. Let's see. Okay.
Not a problem.
None that they can think of. All right. They told me they don't have any questions. Let's see if I have any more. I know Denison, that's I remember going to track meets there because I did track in college.
Most people don't know anything about it.
Yes. So I went to Muskingum, which is small and in the middle of nowhere.
In our conference.
It's and so we used to come there for track meets. So I have been to Denison. So I know where it is. I know the feeling.
It's super small.
Mm-hmm.
So, but I actually, that worked perfectly for me. I would have got lost at a big school when I was in undergrad. I'm glad I did that for grad school because the larger schools have a lot more opportunities for in terms of like labs and research.
Yep.
But the way that Denison worked out, it's not known for its physics department. That's not a normal thing. They have they actually have a lot of pre-med and business, but they don't actually have a business. It's like economics. Anyway, so I graduated with my physics class was 5 people, including me, and I was the only girl. I was actually the only girl in 2 years. Because that was really uncommon then. It's changed completely in the last 10 years, 15 years. So so that's really different now. But it was nice because like I said, one of the things I didn't learn until much later in my college years was how to actually internalize what you're learning. You know, it was easy for me to learn things for a test. So I'd remember it for 2 weeks or whatever, you know, and get through. And having that basically one-on-one kind of classes. I mean, the largest class size I had at Denison was 30 people, like a regular high school class. You know, was good for me when I was trying to figure out what I wanted to do. And then optical engineering is kind of a small program. There's not a lot. There's only a couple of them in the country. So those programs were pretty small too, but actually bigger than the physics program. So it just kind of depends on what you want.
My school, because Muskingum is small too. And I was a chemistry major. And I think in like my senior level classes, there were 5 of us, but we were off because they had some classes they only offered every other year. So it was kind of a combination of 2 years.
Yeah, so we did a lot of those too.
Yeah. When you were looking in terms of going to college and things like that, what did you look for in your process of applying? Did you apply to a bunch of places? Did you kind of know what you wanted to do, or what kind of helped you end up at Denison?
I did apply to a lot of places. One thing I did actually both times I applied for schools that I wish now in hindsight that I hadn't done is I looked very local. So I'm from Ohio. I stayed in Ohio. I think the only out of state schools I applied to was Purdue and Carnegie Mellon, maybe. I think that was it. At the time, let's see, for undergrad, I did that. My connection's unstable. Hopefully I'm not freezing. There we go. For undergrad, I thought I would save money by doing in-state. But then I went to Denison and I didn't save any money because that place was very expensive. And then for grad school, it was kind of a similar thing. I just wanted to be closer to home so that I could get home. But I do think that limited my options, you know, and if you're willing to look out and, you know, be brave and try something new, not only is that huge for character development, but it gives you a lot more opportunities in terms, especially in science, because every school is going to have different labs and their professors are going to have different specialties and things like that. So, but that was something I was looking for, was kind of close to home. And a lot of the schools that I applied to, it wasn't until I visited that for me, Denison had the right feel, I guess. It's a liberal arts school, so I like the idea that I could get a broad education, especially for undergrad. I love the small class sizes. That was huge. And let's see. It's kind of funny now in hindsight. UD, when I visited, all they wanted to talk about was basketball, and I wasn't a basketball fan, so that kind of turned me off as a high school senior. But I ended up here anyways, and I actually really like the school. So
that's fair. I went to UC for grad school, so the small undergrad to like a big grad school, that was a good transition. I feel like,
yeah. Now, I know people who thrive in those. You know, at Ohio State, where they're in a classroom for their intro chemistry and there's 200 people in that class. And they're able to, like, I don't know, individualize themselves and make their mark. But that was not my personality. I was much more of an introvert too when I was in high school and college than I am now. So that's changed a lot. But yeah, honestly, it wasn't until I visited the schools that I was able to say, like, Denison was the one I wanted. So I did spend a lot of money. That was something else I didn't do. I did not shop around for enough scholarships. And, you know, honestly, state schools are a really good bargain in a lot of places. But what's great about STEM was I didn't pay for any other college after Denison. So UD, I got a graduate research fellowship. So they actually paid me to come to school. I mean, a teeny tiny stipend, but whatever, it was enough to live on. And then, you know, there's a lot of programs through companies and scholarships, especially for women in STEM. So my PhD is being paid for by work, and my master's degree was paid for. So as much as Denison was expensive overall, that physics degree set me up to get my tuitions covered and waived for future degrees. So it worked out. But it is an expensive situation when you don't really know what you want to do.
Yes, that's true.
Private schools are kind of pricey.
Yes, I talk to my students about go somewhere that's not going to cost you an arm and a leg. Unless they pay you to go there, then totally go there.
Unless they pay you. And there's tons of scholarships, you know, like there's so many programs you can go through. The base has some really cool ones. And I'm sure all companies are like this, but I'm familiar with mine, obviously. Where the SMART program, they pay for your school. So they pay your tuition, they pay you, I'm actually not sure what the going rate is, but they give you a salary too, which was way more than I made as a grad student. And then the only like negative, which I say in quotations, is that you owe them time working for the government. So, you know, you have a guaranteed job for a couple of years right after school.
That's actually kind of nice.
It's awesome. It's amazing. And the SMART program in particular has a 1-to-1 payback. So for every, you know, year that they pay for, you owe them a year. For my work that I'm doing now, it's actually a 3-to-1. So I owe them a lot of time, but whatever. Having a guaranteed job is part of one of the things.
I think that's, I had a lot of friends that came out with, they didn't have a job in what they did. So something like that, you have a job, which is good. And it's probably something you're interested in doing.
Yeah, there's somebody interested. Yeah, and they're invested in your career. So so that was huge. And I wish I'd known about that program before I did my master's degree, but I didn't. So
yeah.
But yeah, and then a lot of colleges will do, for me, it worked out that I went back. So I did my master's right away, but then I went to work because getting a PhD is a little bit different. You know, you're going to become an expert in whatever you study. And I wanted to make sure that I liked what I was doing. You know, how do you pick what you're going to get your PhD in? So I went to work, and that helped in a lot of ways. Not only did I have a completely different perspective on school when I went back, because I could apply it to things that I'd seen in the real world. But I also, you know, there was some research that I've been doing now for 8 years, basically, and only 4 of that has been for my dissertation. So it really helped me pick what I wanted. And then the benefit of that was I was already employed, and my employer is paying for my PhD. So so it worked out for me.
That's a good deal
overall. Yeah, because some places, it really depends on what you're doing. I don't know about some of these ones that your students have picked out, but there are some careers where getting the highest level of education right off the bat isn't always beneficial. It's a little bit harder to find a job, whereas that work experience, you know, can help you get your foot in the door a little bit quicker. But like I said, anytime you could do internships or work or get referrals from places because you've worked with them and you've been there and done it, you know, it makes a huge difference when you're trying to apply for jobs or get into schools. So
and it is kind of in the biotech industry, it's like all ranges. Like you can get a job right out of high school all the way through having, you know, your doctorate to be running a lab or working in, you know, industry or different things like that. So it's kind of the whole gamut of options. Most of the time I try to talk with my students, like, what are you interested in? And let's work backwards from there to figure out what is the best path.
Yeah.
So like for forensic
That's
toxicology,
a really good way to do it.
Forensic toxicology. Hey, Sarah. I know this one just because I have someone as a friend who is a forensic toxicologist, and like she knew she wanted to do that. So she found out she needed to major in chemistry. And in Ohio, nationally, there's like I forget what it's called, accreditation. And the only college in Ohio that's accredited is OU, and they have a forensic toxicology bachelor's degree. So that's how she figured out like where she wanted to go, was kind of a backwards plan. We have a place over here in Kettering, which is the Community Tissue Center, and they will hire people right out of high school because they want to train them with their SOPs and their, you know, protocols and all this kind of stuff. But the things that the biotech students learn in terms of lab safety and regulation and how to work, you know, with your hands in a lab setting can all be applied there. So it's kind of it's interesting to see all the different options. I didn't know about all the options when I went to college, so I'm glad I can share those with people.
Yeah.
Which is why
That's
we wanted to have you
incredible.
come
Man,
talk.
I wish my high school was like that. Yeah.
Well, and I'm at my high school, so I went to Fairmont. And this program it started like 3 years after I graduated. So it's kind of fun to be back now and running this program. But
Wow.
I am a little jealous we didn't have it when I was here. So hopefully I can impart some industry knowledge to my students and things like that. But that's why we wanted to have you come talk, and just have people from the base come, because it's just good to see like what are other people doing in science, because I think a lot of times we don't know what we don't know. And so I appreciate you taking the time today to chat with us and share your experiences. That was really interesting.
Yeah, and I remember when I was younger, hopefully I'm not as old as I make myself sound, but when I was in high school and college, one of my biggest fears was I was so worried about getting pigeonholed that I would do all this training and I would be stuck. Like, what if I didn't like it after I got stuck in it? And it's not like that. You cannot get stuck. You guys are learning, especially right now, so many transferable skills. And when you understand that, you know, that like you're going to college, it's not just about, you know, the facts and figures, because frankly, anyone can ask Alexa, you know, what the equation is for some of these chemistry problems, but understanding, you know, how to problem solve and use that information. And, you know, it's those skills that you learn along the way that are really what you're going to use in the future. And you could do that. You can apply that stuff to anything. In fact, being able to market yourself is something they do not teach STEM students how to do. And that's a hard one. You know, being able to stand up for
I'm
yourself.
not sure I even know how to do that.
Yeah. I've had to learn. That's part of our annual evaluation. So I'm learning. That's something I'm teaching myself right now, is how to market my skills and stand up and say like, no, this is what I'm good at and I know how to do this. And once you figure out what your abilities are, being able to apply them to other things becomes a lot easier, you know. So I could take my research and do all kinds of work if I, you know, got bored, I guess, you know, and wanted to try something else. It wouldn't be a huge leap or whatever. So you're never really stuck.
Yeah. Sorry, they're talking to me. That might be something with my seniors, to have you all come back and do some kind of panel or something like that on how to market your skills, because I think that that's something that will be really beneficial really to any of my students.
Yeah, the biggest key is figuring out what the customer wants, who you're marketing to.
Yes.
And then you can spin your work. I can spin my work to sell it for anything. I'm telling you. I can convince you to use laser radar to solve any problem.
I think that sounds great. Let's do it. See it work.
Yeah, I can make that work.
All right.
Might not be the best problem, but I could teach you how to do it. You know?
Yeah, that's okay.
So yeah, but marketing is huge. So.
Okay. All right. Well, I appreciate the time that you took today with us, and it was neat to learn about your story and hear the work you're doing. And hopefully that helped us to think a little bit more about our paths and things like that. So thank you very much.
Anytime. So if you guys if you think of questions later or whatever, I'm sure they can find me. So
yeah.
So yeah. Thanks for having me.
Thanks everyone.
No problem.
I'm going to end the meeting now, okay?
Okay, thanks.
Bye-bye.
Bye.
Bye.